Mississippi River in Iowa. So today we're going to get started here and go through some of the features and functions found inside of Carlson Takeoff R10. Today's session is being recorded, and we hope to have the session today along with the remaining sessions that'll be discussed tomorrow and Thursday and Friday posted to the Carlson website later on. So if you don't happen to catch all of today's material or the rest of the material for the content that's going to be discussed later on this week, you can go and find it on the Carlson website. Look for it up on, I believe, our movies page for your review. So today we're going to go through some of these topics. I'm not going to go through and review all this material with you. You can read this, obviously, as you want. But if you do have any questions, the little GoToWebinar control panel will allow you to sort of type those questions in, and Jim will do his best to facilitate answers to those questions as you're going through. If there's any specific questions that we feel are important for the group, we'll try to address those towards the end of the presentation, so we'll try to allow some time for that. So I'll try not to go too long, but by all means, feel free to get those questions typed into the GoToMeeting control panel. So with that, we'll get started. And let me go ahead and get out of my PowerPoint here and see if I can do that without killing my stuff here. So today's topic came to me from a client that was actually looking to get into the product. And one of the first things that he sent me was a collection of PDFs that was part of a bid set. And in this was a dimensional plan, was one of the first ones that we took a look at. And I want to just sort of brief everybody on what these plan sets contain so we have an idea what we're looking for or looking at. And the first one, as we start to look at this, was an overview of the site. And one of the very first things in here was some of the notes. This is a vector-based PDF, thankfully. And a number of the sheets came into me at a 40 scale, and they also contained large numbers of hatching patterns that were placed in here, which sort of added to lots of potential problems, not huge problems. But one of the nice things about this particular plan set was that the building corners, for example, had positional coordinates labeled onto them, so we could use this information. And as it turns out, this particular building was going to be, it's an Ozark Trade School in central Missouri. And we're going to use this information to establish a base plan for the rest of the sites to follow. So one of the things that I wanted to do then was get this building plan set oriented into the CAD environment, but then not necessarily utilize all the stippling effects or the hatch patterns that were placed into this PDF. Secondarily, we had another page from, and these are actually only 5 of probably 90 or so individual little PDF pages that were part of the actual bid plan. So the next one was a demolition plan that came in here. So here were the PDF page that was provided that showed the existing ground contours. Another part of the overall part of this was an existing road that was supposed to be demolished. And one of the things that I wanted to sort of make mention of in here that was sort of noted on the plans was the existing pavement that needed to be removed and the roadbed needed to be filled. And one of the things that was, again, sort of nice in here was that the engineer did a nice job of was showing the break lines for the old roadbed, and we could make use of that information. Again, existing ground contours were labeled in here. And also, this particular plan set was also at a 40 scale, as again shown in the plans. I'm not going to take a ton of time to go through every one of these. This first one in here now, this is where things started to get a little tricky as I was working through my prospective client. And the first phase of the design now, we have a rotated north arrow rotated north of where the building was to sit on the new site. And on this particular plan set, and we'll see this later on today, this actual plan set now was given to us at a 20 scale. So as the prospective client was working through this particular project then, his issues have been that he's been doing all these plan sets by hand. And as we were working through this, one of the things that he had told me was that what had basically been taking him literally days worth of effort to complete a bid set for getting volumes and getting these projects out the door, we were able to accomplish roughly in 2 hours. So one of the things, however, that took a little bit of time and effort to complete was to figure out how are we going to accomplish some getting some things taken care of nicely and easily, and fortunately Carlson Takeoff provides some tools that allows me to remove things that would otherwise clutter up my plan sets. And we'll show you some of those tools here in just a moment. The other little bit of a problem that we ran into with some of these plan sets is, if you take a notice in here, is that as I zoom back out just a little bit, on this plan set, there is a sort of a circular shaped, probably a foyer area in here, and you'll also make notice up and around here, there's sort of this, architectural, I don't know, sort of zigzags little entryway in here. So as the footprint for this building is going to be taken into consideration, this is just not your average square building. So, architects like to be sort of creative. Well, okay, we need to account for that. So one of the things that we want to do then is take a look at sort of this little probably patio foyer area. Well, one of the things that we noticed between this 2.0 and 2.1 plan sheet is that there was some overlap between the sheets. So the match line that was provided for us was not a real exact match line. So if we were to take these two sheets and try to put them together, we would get a little bit of overlap, actually quite a bit of overlap, resulting in potential duplicates of entities. So one of the goals for today's presentation, and in this case Friday's presentation, which will be the follow-up for the OEM product today, again, for those of you who are on today's presentation, I would encourage you to follow up with the Friday presentation to talk about how we're going to deal with the match lines that are going to be needed to make a nice clean break between one sheet to the next. So with all that, again, we've got different scales, different north rotation angles, lots of different hatch patterns, no layers in here. Again, this was straight from the engineer's table to what we need to get out the door. So for the sake of the presentation today, the contractor in this particular situation, all he wanted was earthwork volumes. We didn't really need to go through and establish what would be the pavement quantities and stuff like that. We can talk about that later if we need to, but for the purpose today, we're going to focus on getting basically dirt work volumes for this particular plan set. So we're going to get started. So here we go. Into then Takeoff, I've got a folder here which has a lot of my Carlson icons in it, and one of them is Takeoff R10. So let me go ahead and get started into that. And as I get started with the application then, I'll load into this. And one of the very first things that'll start up in here is a startup wizard. And this will be an application that will allow me to sort of keep track of the different projects that I'm working on. And as it turns out, I've organized all of the PDFs ahead of time into an OTC folder for the Ozark Technical College underneath a Carlson Projects on my C drive. So this is where I'm going to place all the data files for the presentation today. So what I'm going to do then is say I want to create a brand new job, and I am going to then create from a site template drawing that might have some predefined layers in it, a brand new drawing, and the new drawing that I want to create will be up into the folder of my choosing. I'm going to go ahead and browse for the folder that I want in this OTC folder. I'm just going to create how about a base plan drawing, a generic, and I'll just call it base drawing. And I will save this drawing out now. And one of the things that I like to do is to give the drawing essentially the same horizontal plot scale as the PDF that I've been given. So examining the PDF drawing or PDF document from before, it was told to me that that was a 40 scale drawing. And through a little bit of previous investigation, through the details and the address that was found on the PDF plans sheets themselves, I happen to know that the address for this particular site is actually in the Missouri Central Coordinate System Zone. Can show more about that here in a moment, and I'll talk briefly about that once the PDF comes in. So with that, I'm going to say yes, I'm going to be utilizing the state plane 83 coordinate system, and I'm going to specify that this is in the Missouri Central Coordinate System Zone. And for any lat-long datums, I'm going to say that these are in WGS 84 values. So I'm just going to go ahead and choose next. And continue into the wizard. I'm going to validate that the data path that I'm utilizing is the OTC folder. And if I happen to create any kind of coordinate file for stakeout purposes, that is going to be in the general base coordinate file, which is the same name as my drawing. We'll just continue next through our wizard, and that'll take us into the drawing. And inside of the CAD environment now, I have then just a collection of, and I've actually turned off some things. So by default in the software, when you get it straight out of the box, you might actually have what's called the ribbon. I'm going to turn my ribbon on here real quick so people can see what it looks like. The ribbon is actually a larger panel of tabs and panels and things that tend to, in my opinion, clutter up the display. I like to turn the ribbon off. I'm a guy that likes to sort of maximize the screen space on my computer. So for me, I like ribbon close is one of my very first commands that I tend to run when I get the software. So I turn off the ribbon by ribbon close. That gives me a little bit more screen space here, and I can get to all of the commands that I like very quickly through the file, through the menuing system that's available up on the screen, and or through the collection of toolbars that I can customize by simply right-clicking and going to Site and then choosing whichever toolbars are of interest to me. So now that I've got the software environment roughly customized the way I like it, what I'm going to do then is indicate a PDF that I want to bring in. Now, it turns out that I actually have a PDF shortcut right here. It's docked. It's the Import PDF toolbar that's right there docked on one of these toolbars. If I didn't happen to know where that was on my toolbar palette, I can also go to the File menu, come down to to the Import command, and I can say I want to import PDF file. And when I come down to the Import PDF, out to the folder where I have my documents, I'm going to say, go grab the 004 C1.1 PDF file. Now, ideally, in an ideal world, we're going to have a PDF that will also contain layers. That makes life very nice and easy for me. But as it turns out, this PDF did not have any layers, but what we can do then is utilize colors in that PDF for the layers that will be being brought into this drawing. And I'm going to skip over all these toggles for right now because this will let me make the decisions about what's going to be important for the work that I want to do. And with these options turned off, all I'm going to do is choose the Insert Line Work button here. And then we'll process the PDF. And then down at the command prompt, down here at the bottom of the application, it's going to prompt me here in just a moment. of where on the screen do I want to place this PDF. I'm just going to pick an arbitrary spot on my screen with a left click. And now, what kind of rotation angle do I want? And I'm going to accept the default value here with a enter or a right mouse click, and just press enter for the default value 0. And now, what horizontal scale do I want? And I'll choose a default value of 40. A 1 inch equals 40 was my PDF default scale. And it'll bring the PDF in here in just a moment. Now this, again, PDF had lots of hatch patterns in it, lots of little line work items in it, so it's got a lot of material in here that we need to process. So this will take a couple of seconds to bring in. And ultimately then what we're going to use is the positional data of this first PDF as a reference position for the other PDF documents to follow. So we're not going to use a lot of the material in here. We're going to use this first one, like I said, as sort of a place marker or an image map for the other real data that we have to work with. So, like I said, this takes just a second or two to bring in because, again, with all those hatch patterns that have been placed into that PDF, this does take a moment or two to process. So, as we are processing all those objects, you can see the little process bar down here in the lower right of my screen. It will cook through here. And now that we're done, we have a blank screen. You can start to see the very tail image of the border right here at the very top of my screen. To see everything visible on my screen, I'm just going to choose the View menu, and I'm going to say I want to go and say, for me it's View Extents, or for me it's just Zoom Extents. There it is, Zoom Extents. Quickest way for me to do it is just ZE for Zoom Extents. This is the quickest way to do it. But there is the first version of the PDF that I want to look at. So now that we have that in our drawing, what we want to do then is say, okay, now we've got it in here. Do the coordinates that we have in the drawing match up with the coordinates that have been annotated into the drawing for us? And before we do that, one of the things that I'd like to do is potentially get rid of some of all this extra hatching and stuff that's in here, because that's just sort of clouding up our drawing, if you will, and it's sort of slowing things down. So because that hatch is all intertwined with other parts of the map, and we can always get it back if we need to by just simply re-importing the PDF, or maybe we can just freeze it. I guess we can do that too. It doesn't really matter. Let's see here. I don't know which way I want to go. Maybe we'll take, I guess I'm waffling right now in terms of which way I want to go. We'll leave it in there for right now. Okay, how about this? So I'm going to go ahead then. You can see the very tip of this arrow here then is coming right out to the end point of this building corner. So what I want to do then is reposition that tip of that arrowhead to these more precise easting northing coordinates. And it turns out then I've got another pair right over here that is just another hard to see spot right over here. So lots of line work is going on, and what we want to do then is be very precise with the positioning of all this data to new locations. Now, typically one of the very first things that I do as I bring any PDF in is I like to validate the dimensions of the PDF against a predetermined distance that I already have known. So is this bar scale accurate, for example? So I'm going to do a quick inquiry in here. So I'm going to go to my inquiry menu. I'll come down and just choose a standard distance command. So let's just go and run, for example, angle and distance. I don't really care about the angle part of this. And let's just go from points, and let's go from the endpoint of right there over to that endpoint right there. And it says horizontal distance was 120 feet. Okay, so we knew going from 40 to 0 and 0 back out to 180, that's 120 feet. So we know that we're in good shape. All right, now with the distance validated, then what I want to do is say, okay, let's take all this data and let's get it aligned to the coordinates as determined by the engineer. So I'm going to go to my edit menu, I choose align, and we're going to do a 2D alignment. And it's going to ask me for the entities to align, and I'm going to say all entities in the drawing. Type in the word all at the command prompt, and I'll press enter. And we've got whatever that number is, like 163,000 plus entities. So I'm going to go ahead and say, okay, that's what I want. And the very first source point, and I'm going to window in with my wheel button on my mouse, will be the endpoint of that arrowhead right there. And now in CAD, I have to choose an X comma Y coordinate. So I have to be, this is where I want a good typing skills in here, 2006.2893, comma, and now my Y value, 466.248.4428. If I got that, it's going to be 4428. I think that's right. And just double check my numbers here. I think that looks okay. And once I have that first coordinate in there, then I'm going to wheel out and then roll into another area, usually as far away as I can get to avoid any kind of scaling distortions, and I'll repick right there and then give it that coordinate location and say that that one needs to go to 135.1763.3097, comma 466.206.4950. And based on the numbers that were provided and the scale factors and the distances, it would say, okay, there was a determined scale factor of 0.99988, so about is very close to 1. Do we want to scale everything in the PDF as a result of these alignment points, yes or no? The default value in here is no, so I'll just say no. Let's just say that, this could have been rounding errors based on, the values that were selected in here. So I'm just going to say no, leave everything scaled as it was, and just get it all moved off into the new coordinate location. So it's going to then take all 100+ thousand objects off into their new spot. And what we're going to do then is isolate then some new entities and then further validate that they are where they need to be. And we're going to do that by exporting out just a few of the pieces of geometry out to Google Earth and make sure that things are where they need to be. So with my data now in the proper Cartesian coordinates, I'm going to zoom extents. That's my shortcut for doing things. And I'm going to save my drawing. And let's go ahead now and isolate maybe just the road polylines in here. Those are probably something that's been existing that's out there. So I'm going to go ahead and say view, and I'm going to say isolate layers, and I'll pick up on some of these road polygons that are in here. And yeah, that's good enough. Now let's just, how about this? We'll just say view, and we will freeze layer by pick, and we'll get rid of some of this hatching maybe some of this other stuff. Oops, go ahead and rerun this here, pick up some other stuff, and some of that annotation. There we go. So maybe there's some of the existing utilities that were out there, some of the existing road stuff that's out there. There's a little bit of stuff that's left. That's good enough. That's enough just to say, let me know that, hopefully it's enough to find out what I should have left. All right. So with this material that's left, now I'm going to say File, and I'm going to export out to a Google Earth file. Where's my export? Where's my export Google Earth file here?
Bottom of the list, lad.
Oh, there it is. I'm sorry. Thank you, Jim. Can't see the trees through the forest. Okay, so export Google Earth file, and then all I need to do here is go ahead and just choose what I want. In this case, I don't have any elevations in here. I'm just going to go ahead and say OK, and I'm just going to write out a g-base KMZ file and just write out maybe that collection of items, and we'll see what we get. So with this subset of data now, I'm going to make sure that the data does fall where it needs to fall in the Missouri Central coordinate system zone. And sure enough, and this will be hard to see here, probably for the sake of, let's go ahead into the properties of this guy, and we'll say for the style and the color, we'll change it from gray to maybe black, and we'll say OK. So maybe that will show up a little bit better here for you on the screen for the presentation. So now we can see that for the sake of the recording here, that yeah, we are basically right where we need to be. Now, with this material then properly georeferenced, we can say, okay, we have then an existing road that looks like it's already been more or less abandoned, that we're going to have to then, the contractor is going to need to remove and fill in the old road bed. Well, it'd be maybe a fair bet to say, well, maybe this has been dirted over and overgrown with stuff, so maybe there's some old concrete out there. What if we were to utilize some mapping tools in Google Earth to aid our cost estimating process inside Carlson Takeoff? So I'm going to go ahead and turn off that polygon. There's a collection of polylines that are in here, and I'm going to draw in a freeform polygon inside of Google Earth and use that for work to follow. So by creating now, up in my toolbar in Google Earth, I have the ability to add a polygon, and this will be I'll call it V-demo for demolition. And I'm going to simply draw in, by doing a left click, areas where I want to say where this road bed exists. And I'll just draw a straight up line up here. And maybe that is the shape of the road bed that needs to be removed. And if I need to, I can take any one of these little red blips that are on my screen, and I can change its position on here. So if I made a mistake or anything like that, I can move it around, and change its position. If I want to change the style or color, I can make it, more opaque, and say, okay, maybe it's easier now to see. Oh, well, I could move it in, move it out, whatever it is. So now that I have a better idea of where my road bed needs to be removed, and the ultimate area that I have to be responsible for, I'm going to go ahead and just say OK. And I'm going to then right-click on that polygon that I just drew in and say Save Place As. And I am going to go out to my OTC folder and save it out as a V-demo KMZ file. So I just wrote one out of the software called G-base. Now I'm going to go the other direction and save one out of Google Earth into my folder called V-demo for survey-demo. And there it goes. So now that I'm done with that, I'm done with Google Earth for a while, so I'm going to go ahead and close out of here and discard my changes out of Google Earth. Okay, so now that I'm good with my base map, I'm going to go ahead and restore all my layers and turn all that stuff back on so we can see it. Except maybe I don't want all that other hatching and stuff, because again, that does sort of clutter things up. So if I go back underneath, well, no, it's for what I need right now. I'll just leave it in here. It's gonna probably get in the way. Maybe it won't. I haven't actually gone through the exercise here now of leaving this all in here. So this might come back and bite me, but that's okay. So I'm gonna go ahead and save my drawing and move on to the next part now, which is getting the existing ground contours and the road bed all taken care of for the existing ground material. So to do that, what I would normally do, like to do now, is start a brand new drawing. Since we have individual PDF sheets, I want to go into and work with individual drawings. So again, I'm going to go File, New, and with the same site DWT file, I'm going to create up a brand new drawing name. And one of the things that I typically like to do is work with a file naming convention that sort of conforms to the layering convention of the National CAD standards. So in the National CAD standards, G is for general, V is for survey, C is for civil. So if I have G was for a general base plan and V was for surveyed, I'm going to have a V dash, maybe existing drawing, survey existing drawing. And I'm going to go ahead and save this drawing now. Again, this was going to be a 40 scale drawing, and this was also going to be in State Plan 83, Missouri Central. And same data path, and for any points for stakeout, here's where they would be placed. We'll go ahead and choose next. Now, the very first thing that I want to do, though, is I want to reference the external reference of my general base plan drawing into my survey existing drawing. So if I go to File, XREF, and go to my XREF Manager, I'm going to attach my OTC GBase drawing, and its insertion point will be at 0, 0, 0. Scale will be 1. Rotation angle will be due east. Basically just plain Jane, everything is 1, 1, 1, 0, 0, 0, and east. I also like it as a relative path so that if I happen to move these drawings, move them all as a set, everything is consistent. I don't have to worry about hard-coded paths. I can just, everything makes it easy to move things onto jump drives, and it's just easy and transportable. So I'm just going to go ahead and say OK. And with that, I will have then a external reference being attached into my survey drawing. And what that will let me do then is get to the geographical position of my first plan set without really physically having too much data in my overall survey drawing. So I'm going to do a quick zoom extents. And that'll take us out to the limits of our drawing in here. And then I will go ahead and import the PDF of our existing ground demolition data. So there we are. Now we're should be in the proper coordinate system zone. So I'm going to go to my little shortcut now on my toolbar and import what will be the C1.2 drawing PDF. So I'm going to go out and grab 005 C1.2. There it is. We'll open it up. And the reason I X-reference this in here right now is so that I can place the PDF here nearby. And again, use colors for layers, keep all the rest of these guys off, and just say insert line work. This will come in very quick. And the insertion point to pick it will be right there somewhere. Rotation angle, again, is 0 is fine. Scale factor, again, should be about 40. Should be 40. And that will come in pretty quick. And then once that PDF is in there, there it is. Then all I have to do is find a common spot between these two sheets and get this one moved down to here. So it turns out that it looks like the property corner down here in the southwest corner of the site is shared between these two spots. So I'm going to go ahead and just simply issue the edit move command and move that collection of objects with a base point of, and I'm just going to go ahead and choose an endpoint. I like the very precise endpoint snap here to make sure I get the right one. And go from the endpoint right there. I'm going to roll out with my mouse button and then have to sort of go to the endpoint of right there. And with that endpoint snap put into place, the two sheets should be lined up on top of one another. All right. And now they should fall exactly where they need to. Okay. Let's see, make sure I got that here. I don't know if I did. Looks like looks like I did. So, you know, there was also the property line that was in here. That was another angle. And what I could do then is, at this point, all I have to do then is detach the XREF or unload it. So and I get to the point where I get my bad DOS habits from 25 years ago into place. I would simply type in XREF at this point and go into the XREF, and I can just highlight my X base and actually just simply detach it at this point. And now all I'm left with is the original data for my contours in its proper position. And now I can get to work on the original ground contours. And they are, again, properly located where they need to be. So what I want to do now is get all these guys elevated. So I'm going to get to work on doing that. And at this point, now it's just a matter of saying, okay, let's take a peek, and I want to start figuring out, you know, sort of who's who in the zoo. Now, the dark gray ones we can see are, and it's sort of again probably hard to see for some of the parts of the illustrations in here, but the dark gray are the index contours. Lighter gray will be intermediate contours. These are on a 1 foot interval. And what I'm going to do then is go into my view menu, and I'm going to say isolate layers, and I will pick up samples of both the text and the contours that I want to isolate. Leaving then just the things that I'm interested in. Okay, and I've got a little title block in here, that's okay. So what I want to do now then is get these contours elevated. And for the sake of starting this off, the last piece of annotation in here I was at, it was 1345, there was 1344. This must be a 1346. There's a 1347, and it's disjointed right here. So I'm going to say, well, let's say that this first one is a 1347. I'm going to go right to this little, probably a little depression right down in here. So I'm going to elevate all these contours in one shot, going right down to the bottom of that one slope direction. So underneath my Elevate menu, we have a command, Assign Contours, Multiple in Series. And I'm going to change the layers for each of these contours into a layering scheme of my choosing. And I'm going to put them onto something, again, that conforms to the National CAD standards. You might have your own layering scheme that you like. Turns out that I've got my own that I like, which is, again, the National CAD standards. Just to give you an idea, I'm going to cancel the command here. So all the layers that came in from the PDF came in with the C dashes, and so all these are sort of the monochromatic colors from the different PDF shades, shades of gray that came in from the PDF itself. So these don't really mean a lot to me. So I'm not going to use them. I'm going to say these are contours, and as an example. So I also have set up ahead of time my layer library. So I'm going to talk about that just briefly here. So underneath my settings layer library, I have collections of layers that have been I've created that conform to, again, the National CAD standards. So if I get into V, Topo, Major, Minor, for example, they would come in having these colors and layers, and if these layers don't exist in the drawing, Carlson will go into the layer library and create them with these colors for me automatically. We do ship these layers with the some of our products, not all of them, but if you want these layering conventions, we can make them available to you if you want. Just reach out to myself, for example, or somebody in technical support, and we can get them to you very quickly. These come in the form of an LA file. So these are a NCS LA file is what I have here on my computer. So I'm going to go ahead then and just indicate through my Elevate menu again that these are the assigned contours. I did all that. I lost my track. My 1347. Okay. So I want to go into Elevate, assign contour elevations, multiple in series. And I'm going to say for my first point, going from here all the way up to the middle of this spot right there. And we're going to say it's 1347 going downhill. Okay, there we go. And I need to go through my routine here and just double check all that. So as we did all that, let me just double check one more thing. Let's go into my inquiry menu and let's go into my drawing inspector. And I wanted to double check a few things. So we did do that, and I put it on my C topos. Okay, I didn't want that. I wanted a different command. So by using my up arrow key, I can repeat previously used command. So I'm going to go back and hit S for settings, and I want to change the layering to V for topo and V for topo. There we go. And I don't want maybe big wide index contours. I'm going to say OK. And let's go from here all the way up to, again, there. So 1347, again, going downhill. There we go. Okay, so if I happen to make a mistake, it's very easy to change. All right, and as we go through now, then it's just a matter of stepping through the rest of these in here. So again, I can say, all right, well, there's a 1335. So the one thing we just need to keep in mind is as you are going through these, that you cannot change slope direction. So as I work through the next group, I would want to start here, and I can go all the way through that, even that little remnant right over here, making sure that I don't cross into anything that has a, that label, for example, is probably a polyline. So there's 1335 going downhill. All right. And I don't know if I'm going to take the time to do all these guys in here, but at this point, for example, I cannot do something like this. I can't go from here all the way over into this because I would be changing a direction of slope in here. So one of the things that I can do is as I hover on this one right here, here's a 1332. Well, we could probably make the assumption that this is a 1331. So I can say, all right, let's go into here and go from there down into here. That would work. And so I can say 1332 going downhill. All right. As long as, again, I don't change that slope direction. So we can pick this one up here. I can do these also one at a time. So let's make the assumption in here that this is probably a 1334 maybe. So I'll just pick up this guy right there going downhill. And this was a dark gray here. Let's make him a 1330 contour. And we can make this one a, I don't know, it doesn't matter, 13, doesn't matter. So I'm going to pick over two edges of it. It doesn't really matter. It's not going to break it up or do anything crazy. So we'll make that a 1331. And then anything else in here that's really crazy. So some of these are outside of the project zone in here. So let's see here. We'll pick this one up here. So this should be a 1330. And we'll go down and catch up this little guy right in here. So the only thing we do have to make sure of is that we tell it which is the thing that we are first crossing. And again, going downhill. And then we'll pick up this last guy right in here. How about him? 1333. I think this was also, and then the 1332, we'll call him a 1333. And figuring that there was probably some kind of a little, high ridge that was like 1333.33 or something like that in this one little area right in there. Okay, so, and then there's this little grouping right up in here. Okay, so we've got, there's a 1341, a 1340. So let's make the assumption that, let's see here, right up in here, we got these two guys. So we got 1339, and this was supposed to be, I believe, 39 in here. So they're the same kind of thing. So we're going to go ahead and rerun this guy from there down into there, and that'll be good enough. I'm not going to get too crazy about all this because this is offside the project site. So we're going to say 1339, again, going downhill. So for the sake of getting most of this done in here, and we'll get these last two because I do want these. So we want 1347 right here, going up, and then we'll call it good. And say up. There we go. Okay. Question?
So, Lad, we got about 10 minutes here.
Okay, good. All right, so we're in good shape. So now, with that, then what I want to do is also indicate that we have some potential problem areas. If we were to make a surface model right now from these contours, the triangulation would occur across all these contour edges and go across here, resulting in flat spots in our surface model. So thankfully, again, the engineer had provided additional material for us to work with. And as a result, we also have these break lines in here that we can utilize to further control the definition of the surface model that we're going to be working from. So as we go through and work with this, I'm going to go ahead and say, now let's go ahead and say view, and we're going to say isolate layers, and we'll pick up these and that and that. And what I want to do now is say I want to have these polylines also elevated to the contours that we have on the screen. So I'm going to say elevate 2D to 3D now by screen entities. And with this command, I'm going to say what things do I want to convert, and I'm going to pick on the two-dimensional lines that were drawn in for me. And these other guys were just water lines and who knows what, property lines or fence lines or something like that. But there was basically the break lines for the ditches and the road. So I got 4 lines that were selected. I'm going to go ahead and press enter. And the intersection extend tolerance in here for any things that might not match up exactly of a tenth, and I'll just accept that default, which is fine. And now, what are the things that carry the elevation that I want to elevate to? And I will press, I'll type in all objects that are in my drawing, and then whether else in my selection set, I'll press enter, which is good. And do I want to keep the existing polylines, yes or no? In this case, no, I don't think I'll need to keep those, so I'll just convert them. And do I want to set the layer name? Yes, I do. I'm going to say yes. Let's change them to, how about V-BRKL for survey break line. And I'll say OK. Now those get elevated. And as a result, what I have now are both contours at 2D elevations and break lines now at 3D elevations. And as I track along, these 3D polylines now will help control the definition of my surface model to give me better and more accurate volumes for my existing ground considerations. Okay, so we're getting closer. So now, with all this, I'm going to say it's time to create an existing ground surface model, or very close to it. Before I do that, however, there's two other things that I want. I'm going to create, and first off, let me start and save my drawing here. And I want to create a brand new drawing that will be maybe the basis for all of my work to be the start for my project. So I'm going to say File New again, and I'll say Open this up, and we'll go ahead and hit Set, and we'll call this just maybe the OTC project, and we'll hit Save, and we'll call this maybe a 30 scale, which is fine because it'll split our 20 scale for the stuff to follow and the 40 scale that we have, and go ahead and hit save, and then that's good. And what I'm going to do for right now is just insert, draw, insert the block that I have created earlier. See if we can log it out of this other folder. There we go. And I'm going to bring in the survey drawing and explode everything on my screen. So by having just, there it is, the, get rid of this title block part of it here. So now I've got a drawing that contains just the stuff I'm interested in. I'm going to go ahead and say View, Isolate Layers, and actually inside of Takeoff, I'm going to say let's define my or set layer for existing, and the layers that I want to be for existing will be this layer, that kind of layer, and these two layers right there. All right, so I've got topo minor, topo major, and break lines all set to be existing ground classification materials, and we're going to take a look at that briefly by my define layer surface material subgrade. There they all are. The other one that I do want to take into consideration is the polygon that I drew in from Google Earth. So I'm going to go ahead and import that. So I'm going to say File, Import, and let's import my Google Earth file, and that's right there. And when I run the import, I'm just going to go ahead and say, how about vdemo as maybe the layer that I want to bring in just in case. I'm going to say OK. And there is the survey demo KMZ file. We'll open it up, and it just brought that in. So there is the layer that it brought in. And just for grins, we'll change the color of that survey demo layer to be red, just so you can see it a little bit better. And go ahead and say OK on that guy, and we'll just do a change property. Sorry, this is my old color to be by layer. There we go. Okay. And then lastly, what we want to do now is we will isolate the display and turn off other. There we go. So what I want is just the existing turned on, and the rest of the rather the stuff turned off. So did I get this displayed? Other, there we go. And I want other turned on. There we go. Okay, so now what I want is to draw a boundary around this, and then we'll open it up for questions. I know we're going to run a little bit late here. So I'm going to go ahead and say takeoff, draw, and we'll say shrink wrap entities, and we'll put in a V boundary layer, say okay, and we'll put a boundary around all this. There we go. And we can say takeoff, and we will say make existing ground. Oops, sorry. There's a little catch for me in case I don't do something right. I need to go into boundary polyline, and we'll set it up, and we'll just click on the boundary that I just drew. Boom, there it is. And now I can say takeoff and make existing ground surface. All right, so it's going to go ahead and gather up all the polylines and all the data in here. Now, if it happens to find any potential problems with the data that I've got, it turns out I've got 2 T breaks in here that are a foot off. Let's take a peek. All right, so based on the contours that came in from the PDF, all right, well, turns out, just from the data that's right in there, okay, well, do I need to really be concerned too far? Well, probably not, because this is way off the project site, and I'm not too worried about it. Those were the PDFs that, the contours that came in from the PDF. So I'm not too worried about that particular little area in here because they are so minute. I'm not too worried about it. If I needed to, I can fix it up. So I'm going to just dismiss those errors and take a look then at the resulting surface. So I'm going to say view. And we're going to say 3D views, and we'll take a look at the existing surface 3D viewer and say no. And there is our existing ground surface model ready to go, okay, with the definition of our roadway model built in and ready to go right from those contours. Okay. So with that, that went a little bit longer than I had expected. The only thing else that I wanted to do then was start to bring in the design sheet. We can do that real quick if we want, or what do we have for questions, Jim?
Oh, just a couple of, one question really, and that had to do with how we know whether a PDF is a vector PDF or not when you're importing it.
Okay.
To get the line work.
Great question. Okay. Normally when I take a look at PDFs, whether they're vector versus raster, is by a quick scenario of, first off, a visualization, is I will look at them, and a quick way is to zoom in, usually at a really high magnification level. 1600% usually or better will do. So if you zoom in and you get to an area in the PDF where you can start to look at these images, these line works, they'll be very crisp, very sharp on the edges. This to me indicates that it is vectorized. All right, so they don't contain any of the, what we call the jaggies. So when you have a vector PDF, it's going to look crisp, sharp. The lines will have very distinct definition. A raster PDF will have typically come from a scan, and you'll have more of a jagged stair-step effect on the lines. The other common approach or thing that you'll see when you're bringing in a PDF that has raster content only is that it will say the line work button in here will be disabled, and you'll only have the option to bring it in as a raster image, and you'll just place raster basically. At that point, basically, we will attempt to be able to bring it in, and you can attempt to do a raster to vector conversion on it. What's the word I'm looking for? My experience has been that it's usually best to bring it in as an underlay and trace over the top of it, but we do provide some raster to vector tracing tools for you that you can utilize inside of the raster menu up here that you can trace along lines, trace along polylines, and try to work with it. But a lot of the PDFs today are actually come in the form of vectors, but not all of them.
The other is actually more in the form of a request, and that's in reference to items that you're doing at the command line.
Okay.
If you could provide a handout that outlines the options that you're using in those commands to be made available to the folks attending the webinar so that they have that as a reference going forward. After watching the webinar, sometimes they try to run the same command and they're presented with the other questions that come with the command, and they're a little uncertain of how to proceed from there.
Yeah, there's a lot of commands that I know I tend to get lost in my old habits of DOS that are really hard to me to abandon. So one of the things that I do want to mention in here is every one of the commands that I've gone through does have a corresponding help menu topic on. So if I go to the help menu, choose the takeoff manual, for example, you can come through and number one, go through and say, okay, I want to find out about maybe go to the contents, and maybe I want to learn about the elevate, multiple, and series. So I will find the menu command that I'm interested in, elevate, assign contours, multiple, and series, and here it is. And within here, then it's going to say the group C ELEV command, for example. There's one of it. So if I needed to, I could actually take that command. I'm just going to copy that command to the clipboard, and I could, read up on the command, print it out if I need to, or I could even paste that command in here and run it. So all the commands and the documents or the documentation is here available for you on screen at any time. We also have then links for the movies and other support options and all that kind of stuff. There's also the project checklist. That was one of the things that I said, okay, well, missing the boundary polylines. So as I've gone through things, I need to, right now, define the layer target material subgrades. I started to do that. Let me go ahead and redo that. So define, so there they are. The reason I haven't done this yet is because I haven't saved these targets. Save. Now I have a OTC target group that I can recall. And let's go back to my other, because I also had a V demo, and let's go ahead and move to existing. And while we're here, let's adjust for this and say for the edit layer, I'm going to adjust for this and say concrete old, and maybe the depth is maybe 8 inches, and maybe it's I don't know, $20 per cubic square yard. Square yard, wherever my square yard is, there we go, to get rid of. And maybe, I don't know, maybe it's 105 pounds per cubic foot if I want to. Let's make it more. $100 per square yard to get rid of that concrete. And maybe I have to count for another 8 inches of, 8 inches, of aggregate in here. So let's do aggregate, 8 inches. And that is maybe another $20 on top of that. And that's going to be going on tonnage here now. And maybe that's, I don't know, 35 pounds per cubic foot. And let's just say, okay. So as we need to adjust the area bounded by the polygon that I had drawn in there earlier, save and hit exit, there is now that polygon that came in from my layer target from before. So I didn't quite get to the first sheet of the design. We'll get to that on Friday, but we'll bring all that together. So the goal for Friday will be to bring in each of the PDFs that form up the design and form match lines. And for the sake of time, what we'll do is bring each of those in, form match lines, and I will have some of those already done because I don't need to go through and bore you to tears with all that stuff. but we'll bring those all together and get them all sort of superimposed on here, and then bring that into one comprehensive plan. Any other questions then, Jim, that I can answer then for right now?
Yep. Well, one more that just came in.
Okay.
The KMZ files that you create,
Mm-hmm.
is there any reason those could not be viewed on a mobile phone while you're out on the site?
No reason at all. In fact, I've actually done some of that before. You can download Android or iOS version of Google onto your phone, and as long as you can place the KMZ file onto your mobile phone, you should be able to view it. And I've done that successfully with other KMZ files. Now, the only thing that you have to bear in mind is, and let's see here, if I go through and do this right now, let's take a peek here. I don't know if this is going to show up nicely. It probably will. So for me, I like my KML write. So again, I'm the old DOS guy. So if I do KML write is my key in command, it's rather quicker for me to do it that way than going to file export. But if I can just say OK and write this out now to the v-exist and write out all the rest of this stuff. So here's now all the existing ground contours written back out to Google Earth. No, there should be no reason that you can't put this onto any kind of mobile device. Because this is now properly georeferenced, if you are also, GPS enabled out in the field, you should be able to see this material as well. Okay. Oh, now that was one thing I should probably mention here. Let me discard this because that was one other setting in here that I should probably have changed. In here, I also, if you happen to use the use elevation from drawing, which I did, I'm going to drape this on the Google Earth surface, because if you happen to use the Google Earth, the 3D version, if your contours or your data is above or below the ground, if it's below ground, you won't be able to see it. So you just have to be careful with that, because sometimes the Google Earth surface might occlude your data. So I'm just going to say just drop it on the Google Earth surface. That way I can make sure I can always see it. Any other last minute questions as they're coming in?
That looks like it for now, lad. So
Okay.
hopefully everybody can make it to the session on Friday. If not, as Lad mentioned, they're all being recorded and should be available the first part of next week.
Okay. Yeah, and much of this content will be also covered tomorrow in the takeoff suite for the IntelliCAD. So for anybody who's interested in seeing what that product engine can do, we'll cover, again, the same kind of content for tomorrow. So look for very similar kinds of routines. We have some other tools that are available in that product. So we look forward to sharing more material with you there. But again, thank you everybody for your time and for your questions. It is appreciated, and you have yourselves a great remainder of your day.